This is part 1 for lesson 8.2, special right triangles and inverse trig functions. The first thing that you should do, look at the pictures in the first part of your notes and use the Pythagorean theorem to find the missing side of each of the triangles. As you're doing this, see if you notice anything. Okay, you can also find trig ratios to find the missing sides. So I'm going to have you pause the video and I want you to go through it and you're going to find the missing sides. So like this side, this side, this side, this side. So do what you can to find all of those sides. For the first triangle, using the Pythagorean theorem, you would get that this side right here, the longer leg, is 5 square root 3 because it's the square root of 75. For the second triangle, you're going to do 12 square root 3 squared plus y squared is equal to 24 squared. When you do that, remember you're squaring the 12 and the square root 3, so it's going to be 144 times 3, which is 432. You're going to solve it for y. Now, when you solve for y, you are taking the square root of both sides, and so technically you would have plus or minus 12, but it's impossible for this side to be negative 12. So when we're finding sides of a triangle or any length, you're going to ignore the negative square root and just look at the principal square root. So for this one, this side would be 12. For the third triangle, I'm going to first find this side Z, and so to do that I used a trig ratio because I cannot use Pythagorean theorem. I only have one side, so I can't use Pythagorean theorem. So I set it up as the tangent of angle 30 is equal to opposite over adjacent, and so I've got Z over 10 square root 3, and then I'm going to multiply both sides by 10 square root 3. Make sure your calculator is in degree mode, don't forget, because if it's in radian mode, it's not going to give you the same answer and it will be wrong. And then when I solve that for z, I get that z is equal to 10. So I'm going to put that there. So if you haven't already found the hypotenuse now, go ahead and pause the video and find the hypotenuse. The first way you could do this is you could find the hypotenuse, which I'm calling w, by the Pythagorean theorem, since now I have two of the sides. So I would say 10 square root 3 squared plus 10 squared. So I'm taking those two sides, squaring them, and then solving for w. And when you do that, you get that w is equal to 20. So that's one way to do this. Second way you could do this is you can use your trig ratios. So if I say that I'm going to use 30, I would do sine opposite over hypotenuse. I'm going to have to solve for the hypotenuse. So to do that, I'll have w sine 30 equals 10, and then I'm going to divide both sides by sine 30. Again, you have to make sure your calculator is in degree mode. If you have not reset it, then it shouldn't be a problem. It should still be in degree mode from the last time you did it. But that also comes out to be exactly 20. So no matter which way you do it, now of course you could have used the cosine ratio and done 10 square root 3 over w if you did cosine of 30. You can also use your 60-degree angle as well and use sine or cosine there. But either way, you're going to get 20 for that. Now I ask you as you were doing this to see if you could notice anything. So let's take a look at the three triangles. What do they have in common? What is the same about all three triangles? So do you notice that all three triangles have angles that measure 90, of course, 30, and 60 degrees? Did you notice that? So these are special right triangles, and the name for them is a 30, 60, 90 triangle. So it's pretty easy to remember, 30, 60, 90. Okay, so in a 30, 60, 90 triangle, there are some special characteristics. So as you look at all of these, I want you to pause the video and see if you can figure out there's a pattern. Can you find the pattern? Okay, hopefully as you are looking at the pattern, if you look at the side lengths, 5 is my shorter side, 5 square root 3 is my longer side, and then 10 is my hypotenuse. On the next triangle, 12 is my shorter side, 12 square root 3 is my longer side, and 24 is my hypotenuse. And then on the other triangle, 10 is my shorter side, 10 square root 3, and 20 is my hypotenuse. So do you notice that if I take the shorter leg, which by the way, notice the shorter leg is always opposite the 30-degree angle, and that's because the shorter leg will always be opposite the smallest angle in the triangle. But if you take the shorter leg and you multiply it by square root 3, you get the longer leg. Do you notice that for each triangle? That's not a coincidence. That's actually true for every single 30, 60, 90 triangle. Okay, do you notice something about the hypotenuse? Look at the pattern with the hypotenuse. Do you notice that if you take the shorter leg, actually I don't want to erase all of that, if you take the shorter leg and you multiply it by 2, do you notice that you get the hypotenuse? Okay, so that's a pattern that exists in all 30, 60, 90 triangles. And it actually is a very important pattern. So if I say that my shorter leg is x, my longer leg will be x times the square root of 3, and my hypotenuse will be 2 times x. So that's the ratio of the 3 sides. And so if I write like a 3-dimensional ratio right there. Okay, let's go to the next set of examples. Okay, the next set of examples, they're all right triangles. Now this one is not marked as a right triangle, but you know that this is 45 and 45, so this has to be a 90-degree angle. There's nothing else it could be. So all of these are 45, 45, 90 triangles, and so they're also special. Now because they're 45, 45, 90 triangles, we already know something that we didn't know with the 30, 60, 90. Because 2 of our angles are the same, what do I know about the sides? This is an isosceles triangle, so what I know is that if these are my 45-degree angles, these 2 legs are the same. They're congruent. This is an isosceles triangle, so that already gives me a little bit of a head start. So in this first triangle, I would know that this one is 6. In the second triangle, if this is 45 and this is 90, then this would have to be 45, which makes these 2 sides equal, so this one's 14. In my third triangle, because both of those are 45, these 2 are the same. The problem with that one is I don't know either one, so I'm going to have to find it another way. So for all 3 of these triangles, you can use Pythagorean theorem and or trig ratios. So for the third one, you'll have to use trig ratios to find that. You can use Pythagorean theorem for the first 2, though. So pause the video and find the missing sides and look for patterns, and then we'll come back and see that you got that all. Okay, I've got on here how I found the first 2. And so I just set up the Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. So on the one that's green on the left, I got x squared is equal to 72, and when I simplify the radical, take the square root of both sides and simplify the radical, I get 6 square root 2. We're not going to do a decimal on this. On number 14, same thing, I got y squared is equal to 392, and so when I simplify my radical, 392 was 14 times 28, which is 14 times 2, so it's 14 times 14 times 2. And so that's how I got my simplified radical. Now remember, because we're talking about the length of a side of a triangle, the negative square root does not matter, so we do not worry about that. So let's take a look at the third triangle. This one's going to be a little bit different because I have the hypotenuse. It's the sides that I don't have the legs. But because they're the same, I'm going to call them both z. So I'm going to say z squared plus z squared is equal to 2 square root 2 squared. So if I have z squared plus z squared, it's 2z squared. It is not z to the 4th. You're not multiplying. When I square 2 square root 2, I'm going to say 2 squared is 4, and square root 2 squared is 2. So 4 times 2 is 8. And if you think about it, the square root of 8 is 2 square root 2. I'm going to divide both sides by 2, so z squared is equal to 4. And that would make z equal to positive or negative 2, but 2 positive 2 is the one I'm going to look for. Okay, so I've got all my sides. So as you look at that, do you notice a pattern that exists in all of my 45, 45, 90 triangles? This one's a little bit easier to see. If you take a look at your legs for each one, if you multiply by the square root of 2, you get the hypotenuse. And so in a 45, 45, 90 triangle, and you want to make sure you write this down, this is very, very important to remember, and it's going to come up a lot in this unit. So if you have the 2 legs and then you take the leg times square root of 2, that's going to be your hypotenuse. So using right triangles, we actually can do a lot, and we can use it for a lot of different things. So the 2 special right triangles, so here's what you should have written down before. The special properties are as follows. In a 30, 60, 90 triangle, the hypotenuse is twice the shorter leg, which is the shorter leg is opposite the 30-degree angle. The longer leg is opposite the 60-degree angle, and it is square root 3 times the shorter leg. In a 45, 45, 90 triangle, the legs are congruent. The hypotenuse is square root 2 times the leg. So you need to figure out a way to remember the difference between those two types of triangles and what the ratios are. It doesn't matter how big or small the triangles are, if it's a 30, 60, 90 or a 45, 45, 90, this will apply. So using that, let's find the missing side lengths. So in number 1, this is 45 degrees, so this one has to be 45 degrees. So I know that V is equal to 10. Now, because it's a 45, 45, 90, I don't need to do the Pythagorean theorem. I know that the hypotenuse is going to be 10 times the square root of 2 because of what we just wrote. And so that's all you have to do. There's not really any work to show because you just have to rely on what you know about the special right triangles. Number 2, this is 90, 60, so this would have to be 30. And I'm given the shorter leg. So because I'm given the shorter leg, to find the hypotenuse, I double it. Remember that the hypotenuse is the longest side of your triangle, and so that's kind of how you remember which way to go. And then to find the longer leg, I'm going to take the shorter leg times the square root of 3. That's it. That's all you have to do. Okay, so pause the video and do 3 and 4, and then just check back and make sure you got the right answers. Okay, just talking through this one, on 3 we're given the hypotenuse, so if I divide it by 2, I'm going to get 3, and that's going to be my shorter leg. So make sure you don't put it for A, it's going to be B. So B is 3. And then to get A, it's the shorter leg times the square root 3. In number 4, these two sides are congruent, so I know that N is going to be 4 square root 2. To get my hypotenuse, remember you take the leg and you multiply by square root 2. So that's what you're going to do. So you're going to have 4 square root 2 times square root of 2 is 2. So M is going to be 8. So if you did not get those numbers, then you need to stop and examine what is happening there and make sure that you're following. And then you can go on to the next part of the lesson.